Hope everybody's doing well today. Today we are going to talk about the evolution of aerospace engineering. So we are going to start out with um, talking about 1.1.1 aerospace evolution. So this is the evolution of human flight. So why human flight? The desire to fly is an idea handed down to us by our ancestors. They looked enviously on the birds soaring and freely flying through the air. So, what was the first attempt at flight? The first attempt, honestly, was man trying to create wings using bird feathers and jumping off of higher points trying to fly. This was obviously very unsuccessful. So, how did we progress from here? We applied science, technology, and math through engineering. Um, Early aerospace engineering, uh, creative thinking was very crucial. Uh, Leonardo da Vinci, uh, he was one of the very first to come up with an idea that was uh, very capable of happening. However, factors such as technology, they prevented his ideas from becoming reality 600 plus years ago. Um, Thinking lighter than air, uh, designing and flying a lighter than air vehicle really was an important step in human flight. Montgolfier brothers in 1782, um, they they really started putting this lighter than air thought into their ideas. One of the things that really inspired them was they saw smoke rising. Um, then we talk about vehicles that were heavier than air. So Orville and Wilbur Wright, they flew the Wright Flyer on December 14th, 1903. All right. They were best known for their engineering related to the very first successful heavier than air vehicle. It's important to understand that to achieve this, both uh, they had an approach that really was common throughout the practice of engineering. They both were very creative, gained significant knowledge and skills through not only observation, but experimenting and using procedures and different apparatus that they designed. The brothers learned by doing and were able to build their own knowledge and contribute to the advancement of aviation. So, in 1 century, human flight progressed from a flight of 6.8 miles per hour to thousands of miles per hour for aircraft and tens of thousands of miles per hour for spacecraft. So, how was this possible? Uh, by using STEM, science, technology, engineering, and math, and then uh, using basically the design process. Um, they would design, they would test. If it failed, they learned from that failure and they tried again. Commercial aviation really was the catalyst for growth. Um, there were competitions as far as who could create or invent the plane that could fly the farthest, fly the fastest. Just different types of competitions. So Charles Lindbergh was the first nonstop crossing of the Atlantic Ocean in 1927. He won the Orteig Prize as a result of that. Amelia Earhart was the first woman that flew nonstop across the Atlantic Ocean. That was about 5 years after Charles Lindbergh had done that. So, with all of these, the aircraft being created, there was a need for fast transportation. Mail delivery, that was one of the big reasons. You're able to get your mail across the country and even across the ocean much faster. And then paying passengers. They figured out this was a way to create uh, an opportunity to make money. But then the military got into it, and they really started World War One through the start of World War Two. The engineers started to develop more efficient aircrafts and better engines. During World War II, the demand for aircraft was extreme. Advances in aerospace engineering and manufacturing capability really made this possible. They improved aircraft performance. They created navigation aids such as radar. And then they really started to increase performance. So supersonic flight was something that they really started to uh, reach for. Aerospace engineers, they continued to learn, continued to develop. Uh, in 1946, Captain Chuck Yeager, he flew Mach 1 for the first time, which was basically around 700 miles per hour. Um, the big thing with aerospace engineers is that they continue to develop. They're continuing to make commercial aircrafts, improve on those. And then personal general aviation aircraft, so personal planes. And then we started seeing sports such as hang gliding and stuff come into existence. So going back to Leonardo da Vinci's ideas, he came up with the concept of a helicopter in 1480. Um, Igor Sikorsky, he engineered more of a wide scale production of helicopters in 1944. And it really, a lot of that stuff was based off of Leonardo da Vinci's ideas. Once again, they design, they test, they fail, they learn, they improve. Um, then we get into the small unmanned aircraft systems. So these are more like your drones. And then the Federal Aviation Administration, the FFA, it uses it as a small unmanned aircraft system, or an SUAS. It's also your drones, your multi-rotor, tricopter, quadcopter, hexacopter. Uh, these are all unmanned aerial systems or unmanned aerial vehicles. Um, Anything that is greater than 55 pounds, or sorry, greater than 0.55, so greater, a little over half a pound, but less than 55 pounds, they've got to be registered, and you have to stay away 5 miles away from airports. You have to stay under 400 feet of altitude. You need to have a line of sight on your drone. And some of the purposes for drones is educational and recreational flying. And then also for work to get paid for it, you have to have your remote pilot airman certificate, which you get through the FAA. So drones, especially recently, have become extremely more more in use. The global market is valued around 127 billion, and what they use these for, all kinds of stuff, infrastructure. They're used to do different types of monitoring and stuff, basically checking out general structures and facilities, roads, power systems. They can do all of these inspections much faster with a drone. Agriculture uses drones, transport, security, media and entertainment, and then even insurance and telecommunications and mining. So we're going to go back to space flight. Um, rocketry really was kind of the first way of looking into getting into outer space. Uh, the Chinese were credited as using uh, the first kind of rocket uh, using black powder in 1232 AD. Now, this definitely was not. This is more fireworks than like putting a man into space. Um, then the Russian space scientist Tsiolkovsky, he developed equations in 1903 to actually try to get somebody into space, but yet still the technology was just not there. Um, Robert Goddard, he's considered the father of modern rocket propulsion. Um, he helped create and launch the first liquid fueled rocket in 1926. Then the space race really started to come about between the United States and uh, then Soviet Union, now Russia. Um, Similar to when Charles Lindbergh crossed the Atlantic to win his prize in 1927, the Soviets were the first to put a satellite in orbit in 1957. The Soviets were also the first to put an animal in space in 1957. The United States launched their first satellite, which was Explorer 1, in January of 1958. The US passed the National Aeronautics and Space Act, which created NASA in October of 1958. President Kennedy proclaimed in 1961 that the US should commit to landing on the moon within the decade. And the big thing was, how is this going to be done? And that's what the US had to figure out. There was 9 years of intense engineering. There was failures. There was learning that all helped to make this happen. So America won the race to the moon. On July 20th, 1969, Neil Armstrong stepped on the moon as the very first human. Engineering is the foundation for continued exploration, and we are still exploring space, whether it be different meteors. We're still exploring Mars. We're still looking into other planets. Basically, competition drives accomplishment. And that really was the first, or really what helped lead to all of these first accomplishments. So what's next? Well, aerospace engineering is still, they're still sending rovers to Mars, trying to learn more about that planet. They're still sending different types of satellites and everything out into space. It really is just trying to learn more. And that's what aerospace engineering is. Let's improve what we have. Let's learn more. And this not only goes for outer space, but it goes for here uh, in the on planet Earth and trying to improve what we have here. Guys, if you have any questions, please reach out to me. Let me know. I'll be happy to help you guys out. If not, guys, have a good day.